Hello, and welcome to this presentation on continuous integration and continuous delivery/deployment, or CI/CD for short. In this presentation, I will give an overview of what CI/CD is and why you might want to use it for your projects. Additionally, I will step through a simple tutorial to demonstrate CI/CD. Finally, I'll leave you with the link to GitLab CICD reference documentation, as well as further resources to continue learning CI/CD in depth. So let's get started. So what is CI/CD? Short for continuous integration and continuous delivery, or continuous deployment. It is a set of practices and tools in software development that aim to automate and streamline the entire software delivery process. CI/CD helps to combine development and operations, or DevOps, by requiring automation in building, testing, and deployment activities. CI/CD is a philosophy and practice that, when put in place, promotes frequent, reliable, and efficient delivery of applications. First, continuous integration focuses on regularly merging code changes into a shared repository, which triggers automated builds and tests, ensuring that the codebase remains stable and reliable. Second, continuous delivery extends this process by automatically delivering the successfully tested code changes to production or staging environments, allowing for faster and more frequent software releases. Releases are still manually triggered with a human in the loop, however. Finally, continuous deployment is an extension of continuous delivery with the addition of automated software releases. So why use CI/CD? What are the benefits? Some of the key advantages are listed here. What it comes down to, though, is engineering software faster, better, and cheaper. We will be using GitLab to demonstrate a CI/CD pipeline. To start, it is helpful to understand some of the common terms used in GitLab CI/CD. The GitLab ci.yaml file sits at the root level of the project directory. This file provides the pipeline definition for the CI/CD process. It is a list of all the steps to take for the build, test, and deployment stages for the application. GitLab features a web-based pipeline editor with some nice features including syntax checking and quick committing. However, the pipeline definition file can be created with traditional command line or GUI text editor applications. Runners take the instructions in the pipeline definition file and execute on physical or virtual machines. Furthermore, the pipeline definition file can specify Docker container images to use so that the build process begins in a specific environment with supporting dependencies largely already provided. You can use runners provided by GitLab or register your own customized local versions. Pipelines are the conduit in which committed code enters, is built, tested, and deployed to a production environment. Pipelines are subdivided into stages and jobs. Default stages include build, test, and deploy, but custom stages can be created in the pipeline definition file. Stages consist of one or more jobs. Jobs define specific command lines to accomplish a goal. CI/CD variables are like traditional exported environment variables. Variables help customize jobs and reduce duplication. Variables can be created in the pipeline definition file, project settings, or sourced from predefinitions based on the project, user, and build environment. A component in this context is a reusable pipeline configuration unit. They can be included in pipelines to reduce duplication and ease configuration management. Artifacts are files generated by jobs that can be passed between jobs and stages. They are typically used to share build outputs or testing results. With some basic terminology out of the way, let's get started on the GitLab CI/CD tutorial. To start, make sure you have a project in GitLab ready to add CI/CD support. A basic free GitLab account will suffice for this tutorial. Create a new blank project with any name you choose. You can choose to have an initial README file added to the project repository, but it isn't necessary for this tutorial. Next, on GitLab's left toolbar, select Manage and then Members. Verify that your user account shows a max role of owner or maintainer. Next, we need to make sure that runners are available to execute the CI/CD jobs. On GitLab's left toolbar, select Settings and then CI/CD. Next, scroll down to find the Runners section and click the Expand button. You will see a list of project and shared runners. If this is a new, basic GitLab account, the Project Runners section will be empty. Ensure that in the Shared Runners section, there's at least one runner listed with a green, active circle next to it. If all requirements are met, then a runner is available to process the jobs in your CI/CD pipeline. If a runner is not available, there is the option to install a GitLab runner on your local machine and register it for this project. This is beyond the scope of this tutorial, however, and a free GitLab account with a new project should allow for sufficient runners. Next, we create the GitLab-ci.yaml file with our pipeline description. We will go over this file in detail, but for now, select Code, then Repository on GitLab's left toolbar. A file list should be shown. If this is a basic, empty project, a readme.md file may be shown if you chose that option during project creation. Ensure the repository branch is set to main. Click the plus icon and choose to create a new file. For the file name, type in .gitlab-ci.yml. Copy and paste the text from this slide into the code window. At the bottom of the new file window, add an appropriate commit message, ensure the target branch is main, and click the Commit Changes button. The pipeline will automatically start and run the jobs detailed in the pipeline description file. Next, we will view the pipeline and job execution. On GitLab's left side toolbar, select Build, then Pipelines. You will see the status for your recent commits pipeline being processed. The status will show running until all stages are completed and then will change to passed. Click on the pipeline ID number that starts with the hash symbol to see a more detailed view of the pipeline. Here you can see all the individual jobs that make up the build, test, and deploy stages of the pipeline. Notice that there are 3 sequential stages. However, the test stage has 2 jobs that execute in parallel. We did not specify any custom stages in the pipeline description file, nor did we explicitly specify that jobs should be executed in parallel. How is this accomplished then? Pause this presentation and take a few minutes to look over the pipeline and the description file to see if you can figure it out. Ready? This was a bit of a trick question. Remember when I mentioned default stages? There's an invisible block of code here, like so. If no stages are defined in the pipeline definition file, then the build, test, and deploy stages are defined by default. Now that you know this, you can see that the build, test, and deploy stages are defined in that order. Jobs that are tied to those stages will execute sequentially. First, we have the build job belonging to the build stage. Makes sense so far. Next, we have the test stage with 2 jobs belonging to it. If more than one job is tied to a stage, then they execute in parallel within that stage, just as test job 1 and test job 2 are defined here. The caveat to this is that there must be enough runners available to independently handle the jobs to execute in parallel. Finally, we have the deploy prod job belonging to the deploy stage. It is important to note that the deploy stage, and thus the deploy prod job, will not execute until both test job 1 and test job 2 are complete. Practically, for this simple example, this means waiting on the test job 2 to finish, as it has a long sleep delay at the end. Note the use of variables and simple command line utilities like echo and sleep. This is a simple example, but it shows that any valid command line can be executed for the chosen environment. Back to our pipeline execution. Click on the bubble for the deploy prod job. GitLab takes you to a view of the deploy prod job's execution on the runner. Here you can see the result of all the commands detailed in the deploy prod job section of the pipeline description file. This includes the use of the default Ruby 3.1 Docker image, downloading your project from the GitLab repository, and running the echo command. Notable is the resolution of the CI commit branch predefined variable, which resolves to main, the branch we committed to. With this, our simple tutorial has completed. Today we learned about CI/CD at a high level, explored the reasons for its adoption, and walked through a simple CI/CD pipeline tutorial using GitLab. CI/CD is an important software engineering paradigm that is being widely adopted for its ability to increase quality, decrease development time, and save money. As more software development teams rely on Git as a version control system and GitLab as a code repository platform, the use of integrated GitLab CI/CD tools becomes more common. To continue learning more about CI/CD and GitLab tools, please visit some of the resources on this slide. Thank you very much for viewing this presentation, and I'll see you next time.